In this video, we will be discussing how much energy it takes to change a state of matter. The specific problem that we're looking at today is how much energy is needed to change 11.04 grams of water into steam at 100 degrees Celsius. Before we can begin this problem, we first need to understand where we are on our heating and cooling curve. The substance that we're looking at today is water, and we know that the boiling point of water is 100 degrees Celsius. So 100 degrees Celsius would be here on our graph. Because 100 degrees is the only temperature that they give us, we know that the part of the graph that we're looking at is only this part of the graph, the part where liquid changes into gas, or in other words, where vaporization occurs. Because we are changing state, we know that the equation that we're going to be using is Q is equal to mH. So that's the equation that we're looking at today. Q stands for heat energy, and that is what we are being asked to find in our problem. M stands for mass, and in this problem our mass is 11.04 grams. H stands for heat of. Specifically, in this problem, since we are looking at the change in state going from a liquid to a gas, we are looking at vaporization. So our heat of is going to be heat of vaporization, or HV. According to our reference table, the heat of vaporization of water is 2,260 joules per gram. Now that we know what equation we are using and the information that we have given to us in our problem, we can answer the question. Q is equal to 11.04 grams times 2,260 joules per gram. If we plug this information into our calculator, we would say 11.04 times 2,260, and our answer is 24,950.4. Grams on top cancels out with gram on the bottom to leave us with the unit of joule. Now let's look at the number of significant figures. In our problem, our mass has 4 significant figures. Our heat of vaporization has 3 significant figures. So our answer should also have 3 significant figures. So that would be this place. Because the number after our 9 is 5 or greater, that means that we would need to add 1 to our 9. But if we add a 1 to our 9, that becomes 10, which means that we need to carry that 1 over to our 4, so we would actually be looking at the number 25,000 joules. The number as it is written does not give us 3 significant figures, so we would have to change this number into scientific notation in order to give ourselves 3 significant figures. So it would be 2.50 to give our three significant figures times 10 to the 1, 2, 3, 4th power joules. So this would be our answer in the correct number of significant figures.